YouTube channel KnowledgeStar Continuous Knowledge Excellence. My name is Karuna Singh. In this video, we will get to know about the synthesis of Glycol Chitosan Diethylaminopropyl Copolymer and behavior of the GCS-G-deep copolymer. Now, our expert, Professor Himadri B. Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Delhi Daikin Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobiointerface science, soft matter science, polymer physics, biophysics. Will explain you in detail about this topic. So to get complete information, watch full video without skip.
This is the stepwise that is mentioned here. DAP taken is certain gram is grafted to CGE. This is Glycol Chitosan polymer. This is available commercially. So, and DAP is a chemical available commercially. So these are mixed in DMSO in certain concentration, and triethylamine is used as the binder, and also pyridine is used to enhance or catalyze this reaction. And all these things done at room temperature. Just mix it at room temperature for a day, and then you do a dialysis of this thing because polymer is formed. Dialyze it, and they remove the unreacted DAP through from the supernatant from there. And you could do a visual spectroscopy study to see that how much DAP is still there or it's completely everything has been removed. Finally, the polymer can be collected in the powder form through lyophilization, following by freeze drying. That's as simple as that. So that makes this polymer now ready for use for synthesizing nano gel. This is what is shown here. See, you see here, this is Glycol Chitosan, DAP. This is TEA, triethylamine. They all dissolved in DMSO. And then you have this nice hydrophilic and hydrophobic containing precursor ready for nanogel synthesis.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
Now this polymer, now you see, I mentioned to you that this has got a surfactant-like behavior, but that has to be demonstrated in the experimental data. This is the data for that. This is the micellar CMC we have said earlier, the critical micellar concentration, because this is a polymer now. The term is changed from critical micellar concentration to critical aggregation concentration, CAC. So this, when we say CAC, we understand that the surfactant is actually not a conventional surfactant, it is a polymer type surfactant. So that's why the CAC concentration is plotted here with pH. And you see at acidic conditions, it forms micelles at a very high concentration, something like 90 micrograms per ml. Whereas in neutral pH, the same can be achieved at 1/4 of that concentration, which is typically about 20 micrograms per ml. So this is a property that is going to be utilized there. Secondly, we have to trigger it when it is in the acidic condition, because that is where the cancer location is. So then you see, as you change the acidity of this, the pH of the polymer, it changes drastically, and also change the ionic strength. Also, this changes drastically. So all these things are conducive for designing a platform for cancer therapy using this polymer precursor. Okay, now continuing on. Now you see the zeta potential, this is surface charge on the polymer, plotted as a function of pH. You see below a particular concentration, a particular pH, which is the isoelectric pH, IEP of the polymer, The zeta potential or the surface charge on the polymer is net positive here. All this region, 7 typically to going to 5 in the data set here. And above that, it is a negative. So in the language of biophysics, we call this an isoelectric point where the charge polarity reversal takes place. And exactly at IEP, the charge, net charge on the polymer is 0. Now you see the same thing is reflected here where we're just looking at the solution turbidity, basically how cloudy it becomes. Turbidity is basically measurement of cloudiness, milkiness of this solution, or how transparent it is. Same thing. They're all complementary to each other. If you have only glycol chitosan solution, you see there's no change. It's same at all pH. But for the polymer precursor solution, you have this beautiful behavior of it is responding to the pH beautifully. And at the same IEP that we have identified here from the surface charge measurement, you see there's a drastic change in the transmittance. Transmittance falls because the solution has become now cloudy. Earlier, the transmittance was higher. It was optically clear. It's not optically clear after this. So something is happening to the polymer there, which basically means that there are aggregate formation is taking place, or micellar formation is beginning from that point.
I hope you like this video. Now, I would like to give you an important information that Nanoscience and Technology Consortium, or NSTC, organized the nanotechnology workshops on very amazing and interesting topics. Also, I would like to tell you about the initiatives of NSTC in which you can also be a part of. 1. Mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs, customized training programs, workshops or customized workshops. So yes, that's all. If you want to see these type of informative and educational videos, so please do comment. We will definitely reach out to you. So subscribe to the channel KnowledgeStar and hit the bell icon to never ever miss an update. Thank you everyone.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.